Hey there, this is Fullerene Productions, and we're going to be talking about fire in this video. What is fire? In order to answer this question, let's take a look at what happens if something is burning. Let us imagine a campfire. What can you notice when it is burning? First of all, it's quite literally getting hot in there, so heat energy is being produced. Secondly, you can now see in the dark, because a fire also emits light. And last but not least, if you held your face directly above it, you may start coughing and suffocate because of the smoke that is made by the fire. But let's omit the smoke for now, since we're going to ask the next relevant question here. Where does the energy of the fire come from? We know that energy has to be conserved. Consequently, the heat and light needs to come from somewhere. But where from? The answer is actually quite intuitive. It is the burning material. Imagining the wood or whatever else is burning as the source of the energy is a good way to portray the process. However, there is a problem. How exactly can a lump of wood, which is simply matter like iron or rock, contain energy by itself? This is a tough nut to crack. Luckily for us, chemistry and physics already have the answer. Firstly, we will take a bit of wood and a good microscope, and then we just zoom in. Zooming past the fibers and the molecules, and then we get to the important part, which are the atoms. Wood, as well as every solid material we know of, consists of atoms. And as it turns out, the interaction of these atoms with each other provide the energy the fire produces. And it's also the source of energy in many other processes. But ultimately, that's only a statement. If you want to understand it, we will need a model of what an atom actually is. For this, we will stick with a simple one. Now, just for the record here, this is by far not the scientific standard. It is not intended to be. The models actually used in research are by far not as intuitive and logical. Also, this model will simply suffice for what we want to explain. Okay, so an atom consists of an outer hull and the inner core. The core, which is also called the nucleus, contains on one hand protons, which carry a positive charge, and neutrons, which are of course neutral. In the hull, there are electrons, which are negatively charged. A few important things: protons and neutrons have about the same mass, while electrons possess only about a 2,000th of that mass. Also, the charges on the particles are the smallest there can possibly be, and are of identical value, which means a proton carries as much positive as an electron negative charge. Also, the neutrons are basically there for keeping the core together. They are the ones who prevent the core from bursting out because the protons repel each other. So, for anyone who is interested, the atom depicted here would be an isotope of helium, the one with 2 neutrons. Anyways, this is very important, but why? Well, the atoms can form bonds, and we can imagine this as follows. The electrons of one atom are attracted by the core of another one. So the two of them get closer to each other. The closer positive to negative is, the lower the complete energy becomes, which results then in a release of energy, which can be heat or light. But at some point they cannot get closer anymore. This is where the bond happens. The atoms are fixed in place. If they got further apart, they would be attracted to each other again and they would swing back. But what about if they got nearer? Well, if they got nearer, the cores would start violently repelling each other because both of them are positively charged. But how is this useful? Well, it is as follows. We assume that this graph here shows us the energy levels of the bonds in the wood atoms. How could there be energy created out of there? Quite simple. We change the bonds, so the wood atoms get new bonding partners, and now these bonds are more stable. They might have a graph like this. Between the energy levels of before and after, there is a difference, and this difference in energy is set free. This is exactly what happens during a fire. The bonds inside the wood are broken up and the atoms bond to new partners. These new partners are atoms that come out of the air, oxygen atoms. Since oxygen is a molecule, O2, there are bonds in there already. Those have to be broken as well. That's the basic idea. Of course, in reality, the process is much more complex. Bonds not only have to be always broken, but might only have to be weakened. The idea is basically the same. There has to be an intermediate state with a lot of energy. Speaking in terms of before, that would be when we pump in all the energy to break all bonds completely. This is called activation energy in chemistry, because you have to activate the reaction or the fire. You basically have to spark the fire. After the reaction or the fire has started, it provides itself with energy. There is no additional sparks needed. Well, scientifically you would put it like this. Cellulose is C6H10O5. It makes up a significant part of wood and is a representative of it in this case. The formula means that for every 6 carbon atoms, C6, there are 10 hydrogen atoms, H10, and 5 oxygen atoms, O5. This C6H10O5 can now react with oxygen out of the air, which is O2. And the newly formed compounds are CO2, which is causing the greenhouse effect, and H2O, water. And a lot of energy. That's basically it. So the premise is that the bonds inside CO2 and H2O are more stable than the bonds in C6H10O5, and that's where the energy comes from. An interesting note at the end is that in a fire actually water is produced. Normally you would extinguish a fire with water, however the heat is sufficient to evaporate all of the formed water immediately, so it does not become a problem. Thanks for watching. This is my first video, so please tell me what you thought about it in the comments.